Now see our next chapter, that is thermodynamics. So first we will see what is actually thermodynamics. So these are the introductory terms for the thermodynamics. First one is what you mean by thermodynamics. See here, it is the branch of physics which deals with the study of transformation of heat into other forms of energy and vice versa. So this is the actually thermodynamics, in which we study about the transformation of heat into other form of energy. Now what is for the studying thermodynamics, first we take a system, that is called thermodynamical system. So what is actually thermodynamical system? Thermodynamical system may exist in the form of a solid, liquid or a gas or a combination of two or more states. So first you take a collection of molecules of the any gas, liquid or solid, or the composition of the or combination of the two states in a cylinder which is isolated, and that is considered a system, or that is called a thermodynamical system. Now see here, there are certain parameters which characterizes the thermodynamical system. One is, first you can write here like a pressure, volume, temperature, mass, and fifth one you can write composition. So these are the parameters which characterizes the thermodynamical system. If these parameters does not change with the time, then we say thermodynamical system is in equilibrium. Now see here, zeroth law of thermodynamics. According to this law, two systems in thermal equilibrium with a third system separately are in thermal equilibrium with each other. See here, suppose A and B are the two systems. These are separated by an adiabatic wall. Adiabatic wall means which does not allow to pass heat. It means from this side to this side, A to B, B to A, there is no transfer of heat. It has adiabatic wall, and here between A and C, B and C, this portion is a diathermic wall which allows to pass the heat. So see here, A is in thermal equilibrium with C, B is in thermal equilibrium with C, then according to zeroth law of thermodynamics, A is in equilibrium with B. Now this can be seen here, between the A and B there is adiabatic wall in this diagram. Now it is replaced by diathermic wall, and the system C here which was having here diathermic, now this wall is replaced by an adiabatic wall. So see here, the C is isolated from A and B. Between A and B, wall is now diathermic. So there must be some flow of heat. But when it is observed that here between A and B, there is no changes in the thermodynamical parameters. That means there is no change in the temperature. It means there is no transfer of heat. That means A and B are in thermal equilibrium. So the quantity here which determine the system in equilibrium, that is known as temperature, which is a scalar quantity. So basically here the temperature determines that whether A and B are in thermal equilibrium or not.